Write an expression that fits each description and is equivalent to negative 6x minus 30. The first one says a product of two factors, so that means it's going to look similar to this format. Now we learned this in the second lesson, and we learned about factoring. So what we did in the first lesson was factor out the greatest common factor. But you can really factor out any number that's in common. But let's go ahead and start with the greatest common factor. So the greatest common factor of negative 6x and negative 30 is actually a 6. So we can use that to write it as a product of two factors. So remember, you put your greatest common factor or whatever you factor outside of the parentheses, and to know what goes inside, you just divide it by whatever you factored out. So in this case was 6. Negative 6x divided by 6 is negative x. Negative 30 divided by 6 is negative 5. So then you will go and check and make sure it equals negative 6x minus 30. 6 times negative x is negative 6x, and 6 times negative 6 times negative 5 is negative 30. Now we can pull out another number. Let's go ahead and use a negative 6. Now if we factor out a negative 6, what goes inside of the parentheses? Well, negative 6x divided by negative 6, it is x. And negative 30 divided by 6, it is a positive 5. Alright, so another number that's in common between negative 6x and negative 30, let's go ahead and use a positive 2. So if I factor out a positive 2, what goes inside of the parentheses? Well, negative 6x divided by 2, it is negative 3x. And negative 30 divided by 2 is negative 15. So then you check by distributing back in. 2 times negative 3x, it is negative 6x. And 2 times negative 15 is negative 30. So I came up with 3 different ways. There's actually more, so I want you to come up with one of your own. The second one says a difference of two expressions, each with two unlike terms. So this is how it will be set up. We're taking the difference of two expressions. So that means I have to think of how I can split up negative 6x and negative 30. So I know I can have a negative 6x, and then if I add, I can split that up, negative 6x, as negative 3x and another negative 3x. So I'll go ahead and put that in my parentheses here. Alright, so we have to make sure we're paying attention to this. So I'm trying to get a negative 6x. This one here, I know I'm going to distribute a 1, and I'm going to end up with negative 3x. So here on this side, I'm going to want another negative 3x. But you have to focus. If you put a negative sign here, remember you have to distribute that negative 1 inside of the parentheses. So you don't want to put a negative 3 there. You want to keep that positive, because you know once you distribute, this is going to become a negative 3x, and that's what we want. So I split negative 6x to negative 3x plus negative 3x, and that's what I wanted. So now I have to figure out how I'm going to separate negative 30. Well, there's several different ways you can separate negative 30. So I'm just going to separate it right in half. So I can do negative 30 as negative 15 plus a negative 15. So I'm going to put a 15 over here and a 15 over here. So remember, I want both of those 15s to be negative once I distribute. So if I'm distributing a positive 1, I know I want this to be negative, because a negative 1 times a negative 15 will be a negative 15. Over here, I want it to be positive, because remember, you're distributing that negative sign in, which will be a negative 1. So now let's go ahead and check. 1 times negative 3x, it is negative 3x. And then 1 times negative 15 is negative 15. Now onto this side, I distribute my negative 1 inside. Negative 1 times 3x is negative 3x. And negative 1 times 15 is a negative 15. Now you have to identify your like terms. I have negative 3x and negative 3x, which is negative 6x. And then I have negative 15 and negative 15, which is negative 30. So that brings me back to my original expression. So therefore, this expression, the quantity of negative 3x minus 15 minus the quantity of 3x plus 15 is equal to negative 6x minus 30. Now there's more than one you can do. I'm going to think of another way I can separate negative 6x. So before I use negative 3x and negative 3x, now let me go ahead and try negative 2x. So I know I have to add another negative 4x to equal my negative 6x. And then let's figure out another way I can separate negative 30. I used 15 and 15, negative 15 and negative 15 before. So this time I'll use, let's try negative 10 and negative 20. So this is what I'm going to look for. So I'm going to go ahead and put negative 2x over here, and I'm going to put 4x over here. Now remember, we're trying to get a negative 4x, so you have to remember that you will distribute this negative sign in. So you're going to want to put a positive 4x inside, because once you distribute, it's going to end up being negative. Now I use negative 10 and 20, so I'm going to put my negative 10 over here, because remember, you're going to distribute a positive 1, and you want that 10 to be negative. And over here, you're going to put a positive 20, because we actually want a negative 20. So you have to remember you're going to distribute that negative sign inside. Now let's go ahead and simplify. So remember, when you simplify, you have to first get rid of the parentheses by distributing. There was no number, so I put ones in front of the parentheses. So now here I'm going to distribute a 1 inside of the parentheses. 1 times negative 2 is negative 2x. 1 times negative 10 is negative 10. Negative 1 times 4x is negative 4x, and negative 1 times 20 is negative 20. Now we have to identify our like terms, which is negative 2x and negative 4x, and negative 10 and negative 20. Negative 2x plus negative 4x is negative 6x, and then negative 10 plus negative 20, it is negative 30, which brings us back to our original expression. So therefore, the expression, the quantity of negative 2x minus 10 minus the quantity of 4x plus 20 is equivalent to negative 6x minus 30. These are two examples. I want you to come up with one, and do not use the exact same numbers that I use. Try to think of different ways you can have negative 6x. So I already used 3 and 3 and 2 and 4. So try to think of different ways you can separate negative 6x, and then think of ways you can separate negative 30. The last one says a sum that requires using the distributive property to simplify. So that means it's going to be similar to this second one, except we're going to actually have to distribute numbers in other than 1 or negative 1. So I'm actually going to use this one here, this blue one. I'm actually going to use that as a template. So I'm going to separate this and actually factor this part out. So I'm going to look for a common factor between negative 3x and negative 15. Well, I can actually factor out a 3. So I'm going to put 3 times the quantity, and I have to figure out what goes inside of the parentheses. So remember, when you factor something out, you have to divide each term by whatever you factored out. So I factored out a 3. Negative 3x divided by 3, it is negative x. And negative 15 divided by 3 is negative 5. So I'm going to do the same thing for this one. I'm going to factor out a 3. But we have to make sure we pay attention here. It says a sum that requires. So instead of subtracting like this one, I'm actually going to have to add. So here I'm going to factor out a 3. And instead of dividing 3x plus 15 by 3, I'm actually going to do negative 3x minus 15 again, because we have to remember we're going to be distributing a positive number in, but we want the numbers to be negative once we distribute. So I'm going to put negative x minus 5. Now I'm going to check by distributing back in. So this 3 times negative x is negative 3x. And then 3 times negative 5 is negative 15. Then I have to distribute this one. 3 times negative x is negative 3x. 3 times negative 5 is negative 15. Now I'm going to go ahead and identify my like terms. My like terms are negative 3x, negative 3x, and then we have negative 15 and negative 15. So once I combine the ones in pink, I end up with negative 6x. And once I combine the ones that's in green, I end up with negative 30, which brings me back to my original expression. Another one I can do is I'll use this template again as well. So I'm going to factor out a common factor between the negative 2x and negative 10. So I can factor out either a 2 or a negative 2, but I'll go ahead and factor out a negative 2, just so you all can see how it will look once I factor out a negative 2 or a negative number. So now to figure out what goes inside of the parentheses, you have to remember whatever you factor out, you divide each term by that number, and whatever is simplifies to goes inside of the parentheses. So negative 2x divided by negative 2 is x, and then negative 10 divided by negative 2, it is a positive 5. So now I'm going to have to add. Now I'm going to do the same thing over here. So I can factor out a positive 2, a negative 2, positive 4, negative 4. But let me go ahead and factor out a 4, positive 4. So remember, to figure out what goes inside of the parentheses, you have to divide each term by whatever you factored out. Now we have to focus. So we're distributing a positive number, but we want these numbers to be negative. So I'm just going to put negative signs here because we want it to be negative. Negative 4x divided by 4, it is negative x. And then negative 20 divided by 4, it is negative 5. So now I'm going to go ahead and check by distributing back in. So negative 2 times x is negative 2x. And negative 2 times 5, it is negative 10. Then over here, we have 4 times negative x. It is negative 4x. And then 4 times negative 5, it is negative 20. Now I combine my like terms, negative 2x and negative 4x, it is negative 6x. Then I have negative 10, negative 20, which is negative 30. And it brings me back to my original expression. So therefore, the expression negative 2 times the quantity x plus 5 plus 3 times the quantity negative x minus 5 is equivalent to negative 6x minus 30. So I gave you two examples. I want you to come up with your own. Here's a practice problem. It says write a difference of two products that is equivalent to 5x minus 2y minus 11. Alright, so what it means by a difference of two products is it will look similar to this format. So a difference of two products. That means I'm going to have to distribute something in here and then distribute something in here. And let's use something other than 1 or negative 1. So a hint would be to put x here and y here. Now to figure out what I should do here, what I should distribute in, well, what did I do? What do I need to do to x to get to 5x? Well, I know I need to multiply that by 5. So I'm going to try putting 5 out here. So once I distribute, I end up getting 5x. And then I'm going to do the same thing with y. Well, what do I need to do to y to get to negative 2y? Well, I need to multiply that by negative 2. So I'll go ahead and put this negative 2 here. Now I have to figure out what I'm going to do to get negative 11. So you can think of how you can get negative 11. Well, you know you can do negative 11 plus 0, or negative 10 plus negative 1, negative 9 plus negative 2, so on and so forth. So here, I'm going to multiply, let's put a 1 here. So if I put a 1 here, let's try to get it to a negative number. So I'm going to put a negative 1. And once I distribute on this side, I'll end up with 5x minus 5. And then on this side, I'll distribute that negative 2y. And then I'm going to have to figure out a number. Well, here I already have negative 5. So I can do negative 5 plus something will give me negative 11. Well, if I add negative 6, it will give me negative 11. So what do I need to do to negative 2 to get to negative 6? Well, you can multiply by 3, because negative 2 times a positive 3 is negative 6. So I'm going to go ahead and distribute that in, and I end up with negative 6. So my like terms are negative 5, negative 6, and I need to start combining. So I'll bring this down 5x because there are no like terms. Then I'll bring down my negative 2y, no like terms. And then once I combine negative 5 and negative 6, I get negative 11, which brings me back to my original expression. Here's an example. It says a dog owner wants to fence in a rectangular area for his dog, as shown in the diagram. Fencing costs $5.80 per foot. Part A. Write and simplify an expression for the cost in dollars for the fencing. Part B. The dog's owner has $200 to spend on fencing. Does he have enough money to have the length X be 8 feet? In order to answer part A, we first need to figure out how long the fence is. And when we figure out how long the fence is, we're going to only add up this part that I have highlighted because we're just focusing on the fence. If we include this part here in our calculations, it'll be off because that's not a part of the fence. So there's not obvious answers to where I have highlighted. So we're going to have to piece things together. Let's first focus on this part here. We have to figure out what's the dimension of this part. Well, this one is kind of easy because it tells us it exactly right here. It's equal to x. Now we have to go ahead and figure out what this part is equal to. Now this one is not as obvious because it's nothing that tells us exactly what it is. So let's go ahead and see what's parallel to it. Well, if we look down here, this little portion right here, which is this part, is parallel to this 6 1/2. So this part is actually equal to 6 1/2. Now we have to figure out what this part is equal to. Well, if we look down here, that's equal to x. So this whole part together is equal to 6 1/2 plus x. Now we have to go ahead and figure out what this part is equal to. Now we're going to have to piece it together just like we did this other part up here. Well, let's find something that's parallel. Well, if we look over here with this pink line, that is this portion up here at the top, it is parallel to the one that says is x. Now we have to figure out what this piece is down here. Well, let's look and find something that's parallel. Parallel means going in the same direction. These are parallel lines, and these are parallel lines. Something that's going in the same direction and will never cross. So something that's parallel here, well, if we look right here, that 4 1/4 feet is parallel. So this whole line right here is equal to x plus 4 1/4. Now the last line, it is here. This one is obvious because it tells us right here that part is equal to x. So now we have to figure out what this is all together. So we're going to have to add up all of the values. When we add up the values, we have an x plus 6 1/2 x plus another x plus another x plus 4 1/4 plus x. So all I did was add all of these up to figure out how long the fence is. Now I have to go ahead and combine my like terms. So first I need to identify my like terms. My like terms are x. We have another x here, another x here, and another x here. And my other like terms, it is a positive 6 1/2 and a positive 4 1/4. So now I'm going to go ahead and combine all of my like terms. Well, if I combine all of the x's, I have 1, 2, 3, 4 positive x's, which will give me 4x. Now I have to combine 6 1/2 and 4 1/4. Well, you can change those to improper fractions, make sure they have common denominators, and add that way. But when I do things like this, I like to think of money. Well, this reminds me of $6.50, and this reminds me of $4.25. So when I add $6.50 and $4.25, I end up with $10.75. Or 10 3/4. So when I add up this together, I get 4x plus 10 3/4. And this expression here represents the length of the fence. So this is not answering the first part yet. That just helped us figure out the length of the fence. So if we answer the first part, it says write and simplify an expression for the cost in dollars of the fencing. So this expression here, that does not represent the cost of the fencing. It just represents the length of the fence. So if we look here, it says $5.80 per foot. So this is how many feet the fence is, 4x plus 10 3/4. That's how many feet. But we know each foot costs $5.80. So what we're going to have to do here is multiply. We're going to multiply the $5.80 times the quantity of the 4x plus 10 3/4. But here I changed it to a decimal only because we're talking about money. And normally when you go to the store, you don't say this costs $10 and 10 3/4. You say $10.75. That's the only reason I changed it to a decimal. So now I have to go ahead and distribute. I have to distribute this 5 8/10 into the parenthesis, and then I have to distribute it to the 4x and the 10 7/500. So once I go ahead and distribute that, I get 23 2/10 x when I do the 5 8/10 times the 4x, and when I do 5 8/10 times 10 7/500, I get $62.35. So this expression here represents the cost of the fencing. So this answers part A. Part A is 23 2/10 x plus 62 3/500. Now we have to go ahead and answer part B. Part B says the dog's owner has $200 to spend on fencing. So that lets us know how much the owner has. And the second part said, does he have enough money to have the length x be 8 feet? So now what we have to do is use this expression right here, the expression that represents the cost in the fencing, and we just have to substitute x in for 8. So instead of using x, we're going to use 8. And then we have to go ahead and multiply that and then combine our like terms to figure out how much the owner will spend. Once I multiply the $23.20 times 8, I end up with $185.60. Now I have to go ahead and add those two numbers, and when I add that together, I end up with $247.95. So to answer the question for part B, if the length x was 8 feet, the owner would not have enough money. The owner only has $200 to spend, and the fencing costs $247.95. So therefore, the owner does not have enough money. Here is a practice problem. It says a gardener plans to enlarge a small rectangular flower garden by X feet on all sides and then enclose the enlarged garden with a brick border. The border costs $2.30 per foot. Part A. Write and simplify an expression for the cost in dollars of the brick border. Part B. How much does the brick border cost if the gardener increases the length and width of the garden by 3.5 feet on each side? So here we have to figure out how long, or we have to figure out the perimeter of this rectangle right here. And we can use the formula that we learned in the previous lesson. So the perimeter formula is P equals 2 times the length plus 2 times the width. And remember, we can use this formula because we have 2 lengths and 2 widths. So the first thing you have to do is figure out what your length is and what your width is. So just like we did the other problem, we are going to have to group things together because there's nothing that tells us directly what the length and the width is. So here, this purple line, this will represent my length. So I have to figure out what this length is. So again, there's nothing that tells us directly. So we're going to have to piece this together. So let's look and see what's parallel to these parts. Well, here, this is going up and down. Here, this is going up and down. So this part right here satisfies this part, which is x. And then this part down here goes right here, which is x. Now we have to figure out what this center part is. So we're going to have to look and see what's parallel here. So I'm going to go down my line. These are not going parallel, not that one. So look here, this 5 feet, it is actually going parallel with this part. So that means this missing part is equal to 5 feet. So that means our length is equal to x plus 5 plus x. And then we have to make sure we go ahead and combine our like terms. Our like terms are x and x. So when we combine that, we end up with 2x plus 5. So now we have to go ahead and do the same thing with the width. So we're going to look here. We have to remember we need to piece things together because there's nothing that tells us directly what the width is. So we're going to find things that's parallel to our width. We look here, well, this part and this is parallel to the line. So this part right here, it goes here, which is x, and then this portion right here, it is x. Now we have to figure out what this center part is. Well, let's find something that's parallel to that center part. Well, if we look here, this 7 is actually parallel to this part right here. So that means that is equal to 7. And that lets us know our width is equal to the x plus 7 plus x. Then we have to go ahead and combine our like terms. Our like terms are x and a positive x, and 7 is by itself. So once you go ahead and combine x and x, you end up with 2x, and then you have to add your 7. That means the width is equal to 2x plus 7. Now we have to go ahead and substitute those values into our formula. So we're going to put the perimeter equals 2 times. Make sure you put the length in parentheses. The length is 2x plus 5. We have to make sure we group that together. That's why we're putting that in parentheses. And we have to make sure we multiply the entire length by 2 because we have to remember there's 2 lengths. Now we're going to do the same thing for the width. We have to do 2 times the quantity of 2x plus 7 because that's what the width is. Now we have to go ahead and distribute that. So once we distribute that into the parentheses, we get P equals, and then we have to do 2 times 2x, which is 4x. And then we have to do 2 times 5, which is a positive 10. 2 times 2x is a positive 4x. And then we have 2 times 7, which is a positive 14. Now we have to identify our like terms. Our like terms are 4x and positive 4x. Then we have positive 10 and positive 14. So now we have to go ahead and combine our like terms. Once we combine our like terms, we end up with 8x plus 24. Now this does not answer the first part. This just represents the length of the brick border. So now we have to figure out the cost. And we can figure out the cost by multiplying, just like we did in the other problem. We have to multiply the length by the cost per foot, because this represents the length in feet. So $2.30 times the quantity of 8x plus 24. So now we have to go ahead and distribute that 2 3/10. 2 3/10 times 8x is 18 4/10x, and 2 3/10 times 24 is 55 2/10. So this right here represents the cost of the brick border. So that answers part A. Now part B says, how much does the brick border cost if the gardener increases the length and width of the garden by 3 5/10 feet on each side? So what we have to do here is use this expression right here, the one that says the cost of the brick border. We have to use this expression. And just like we did with the other one, we had to substitute the number in for x. So we're going to do the exact same thing. For part B, I went ahead and rewrote my expression. Then I substituted the increase, the length and width increase, which is 3.5 feet. Now I have to go ahead and multiply. 18 4/10 times 3 5/10 is 64 4/10. Now I have to add the 55 2/10 to that. And once I go ahead and do 64 4/10 plus the 55 2/10, I end up with $119.60. So to answer this question, if the gardener increases the length and width of the garden by 3 5/10 feet on each side, the brick border will cost $119.60.